Gentlemen, welcome to Video Uno by Mr. Kabanga from the Congo. All right, what are we learning today? So today we're going to step up to solving exponential equations, right? So how we go about solving it? We got this. So last week, I believe we learned how to solve when the bases are the same. So you see the base is 10 on the left side, the base is 10 on the right side. If the bases are the same, a piece of cake. So you just take the exponents on the left side, you write it right here, 1 minus x. Then you take the exponents on the right side, which is 4. You write it right here. Then you just solve your basic solving, right? So in this case, when you're solving for this, let me zoom backward a little bit. I'm way too in. All right. So when you're solving, you're going to subtract 1 on both sides. You subtract 1 here. We should have 3 on this side. You have negative x on this side. And then you divide by -1. Divide by -1. X equals -3. That is, when the bases are equal, then you just set the exponents equal to one another. Boom, you got that. Number 2, notice the bases are not equal. Here the base is 81, here the base is 9. But so we got to think about it. How can I make the bases the same? You got this. With 81, let me just go over here, do like a side work here with 81. Over here with 81, you would know that I can do 9 square. Hey, let's use that. So if you do 9 square, right, then you don't forget to bring back that x right there. Just bring it down right here. Put it right next to it. Got it. And then you also have on the right side, it's already a base of 9. So you just bring down whatever's already there as an exponent. All right, the bases are the same. So now you can see the 9 on the left side and the 9 on the right side. Now you can just solve. Solving meaning you just take the exponents from the left side, you write it here, take the exponents from the right side, and you write it there as well. Then you solve for x. Solving for x in this matter, we will have to subtract this x right here. Boom, subtract the x right here. Then you get x equals 2. We're done with that one, right? Moving along to number 3. Now, number 3 brings us to what we need to do today. Today, you're going to learn that sometimes you cannot get the bases the same. So, for example, I have a 7 here, then I have a 5 here. There's no way I can come up with equal bases, right? So what do? Then what you're going to do is what you have learned from us is the log stuff, right? You can apply it here. All you have to do is just rewrite it in such a matter. You're going to write log in the beginning, then you take the entire stuff that's next to it, the whole thing here, you just write it right here, log of 7, 3x. Then you write your log again, then you write the whole thing that's over there, just a 5. All right, and then we continue. You also learned from me last time that if you have an exponent right here with the log, just bring it to the front. Boom. So you should now have the 3x in the front with the log. All right, so let me just make sure I erase. I don't want that to be a distraction. All right, so you have 3, and then you still have your log of 7 on that side. And on the right side, you also have your log of 5. All right, now we're solving for x, right? So what do we do next? This is kind of like a multiplication, 3x times log 7. So what you do next is you're going to divide both sides by log 7. That way, we cross this out. Same thing here, divide by log 7. All right, so on the left side, I just have the 3x left. And on the right side, all you have to do is log 5 divided by log 7. So you think about that. Then you go to decimals. Let's go to decimals. Here, you can just put a log, so click right here, and then you go to function. You go to the last option here, log. What did we say? Log 5. You close that. Oh, close it. All right, divided by, then you do the same thing again, function, the last one, log 7. And the answer is your 0.82. You go back here, you put your, so 0.82. Last step here would be to divide by 3 on both sides. All right, so let's divide that by 3. You go back to decimals. You take that answer, which is a 0.82. 82. You divide that by 3, you get your 0.27 as your final answer. 0.27 is the final answer. Okay? I know it was a lot more step, but it's really not that difficult because we're going to do several of them right now. In this case here, for this particular question here, I need room. So let's clear that because you already have the answer written on your paper or somewhere. With this, we need to get rid of the 1/3, right? Because we're solving it. You're solving it. So to get rid of the 1/3, you can just multiply by 3, which cancel this. Multiply by 3 here on both sides. So you left with the 6 raised to the power of negative 4x. And 7 times 3, you have 21. And then again, you cannot get the same base. You can't get a base of 6 and 21. There's nothing in common there. So what do? You bring my famous log, buddy. So log, and then you just drop whatever's next to it, all of this. You just drop it here. Equals. Same thing. You have your log right here. Log of 21. All right, so as you learned from me last time is you take the power, you bring it to the front. So we should have negative 4x in the front, and you still have your log. This time I'm just going to run log 6 equals this one log of 21. All right, and then you're going to solve, right? You're solving, so if you're solving, you just divide both sides by log 6. That goes out, log 6. All right, let's go find that. Log 21 divided by log 6. You go over here, you type in log 21. Where are you? Log 21. Close the parentheses, divided by log, did we say 6, right? All right, so we did say 6, did we? Yeah, we sure did. So we're getting what, 1.69. So I'm going to go back here and say 1.69 is what I'm getting here. So I have negative 4x equals, what did I say? 1.69. And then you divide that by the negative 4. You go back here. You type in your 1.69 divided by your negative 4. And the final answer is negative 42. Negative 0.42. Is that right? Is that right? That is right. All right, cool. So you circle that, just like that. So let's do now. What I think is easy is this one right here. This is interesting, but I think is also the easiest one is number 5. With number 5, when you notice there's an E here, there's also an E on number 6. E is much easier because you're going to use what we call natural log. Natural log, we use it because natural log of E equals 1. So in this case, instead of using log, you're going to use natural log. And then you drop everything right here. E x minus 6. And then same thing, natural log of 150. All right, so let's continue. You take your 1 minus 6, you put it in the front. So x minus 6, natural log of E equals natural log of 150. All right, what's next? Remember what I said, natural log of E equals 1? You can pretty much just take it away. It goes away. X minus 6 equals natural log of 150. Let's move down a little bit. Here we are. Your next move would be to add 6 on both sides. But before you can just come over here and do natural log of 150 plus 6. Come over here. We're going to do natural log of 150. You close the parentheses, you add the 6 to it. The answer is 11.01. 11.01. You see that? All right. Now let's do number 6. Same deal. Because it's E, it's so much easier. You can just do this again. So it'll be natural log of E. And then you put your 2x in top right there the way it is, a natural log of 3.23. You take the 2x, you bring it to the front. So you should have 2x natural log of E equals natural log of 3.23. You're probably getting tired of me keep saying natural log. And then that goes away. You have 2x equals natural log of 3.23. All right, divide by 2. Divide by 2. You can put this in the calculator and get your answer. Okay, so we have 2 more to go. Let's quickly get that. On this side over here, what I would do is I will subtract 1 here, subtract 1 here. I have 54 right here, so I have 2.35x equals 54. My next move will be to divide by 2 to get rid of this 2. I have 35x divided by 2. What is 54 divided by 2? Good question. I should know this. Shouldn't I not know this? Come on, Mr. K. Isn't that 27? 27. And then this goes back to the basic stuff. But wait a minute. Can I not raise 27 to 3? Yeah, I can do that. Look, I can find a common base. Because 27, you can find that to be 3 raised to the third power. So I should have 3 to the fifth x here and 3 to the power of 3. Then I have the common bases. If I have the common bases, I would just say 5x equals to 3. Let's continue here. 5x equals 3. You divide by 5. You divide by 5. X equals 5 over 3. Hey, let's get the last one. We almost there, y'all. People, hang in there. We almost there. You can always pause this video. Add 5 here. Add 5 there. Let's continue. What does that give me? 21 here. 4x raised to this. There's no way I can get the 4 and 21 in the same base. So what I'm going to do is bring my buddy log back. Come on, log. So you have log of 4. And then you bring your x minus 3 right there. And you also have log of 21. All right, what do we do? Like you learn, you take this, you move it to the front. So you should have x minus 3 log quattro. And you got your log 21. And then you're going to divide by log quattro. Boom, by log quattro. Then you go to the calculator. Let's find out what is log 21 divided by log 20. Log 21, close the parentheses, divided by log 4. Or I said log quattro. That is 2.19. All right, so we have x minus 3 equals 2.19. You add 3, you add 3. That's your final answer. I believe 2.12322 is the value of x. All right, I know this take forever, but you got this.